Howdy, and welcome to Broken Tool Garage. This video is going to go over refining my Flowbench that I have back here that I built about a year ago. I put this together and I didn't quite get it finished. I had to outsource a Flowbench to get my 318 turbo roll head porting that I was doing. I was trying to, what I did was replicate it somewhat Charlie's quickie port. So on that right there, I used this and kind of refined some of the areas. I could get some data from there, but I couldn't actually get flow. So I'm going to go in and get this to where it's working in a functioning Flowbench, kind of the final step to this right here. And this is going to be a big step to take it from where it's at to actually a functioning Flowbench, because, well, basically, I got to make my own flow meter, right? With a mud dauber wasp flying around me. So let's take a closer look. Okay, you see we have kind of our basic deck right there, and then this upper piece right here, where the intent is I can change this plate out, depends on the head that I'm working on, right? This little segment right here, you see the tubes coming in there. What I was doing was I was using the manometer to try to get my measurements for the total pressure in the system, which is the pressure within the cylinder, right? And the velocity coming in. We'll take a peek at what that looks like there. And then the other tube is the one that's only doing the pressure within without the velocity coming into it. The difference between those allows me to pull out the velocity of that using Bernoulli's equation, and given I know the diameter of the cylinder that we're testing in, that gives me area. So if you take and you have velocity, feet per second, and you have area in feet squared, multiply the two together, right? Then you can get your volumetric flow rate, cubic feet per second. So that's kind of the basic idea that we got going on there. I went with this tube because my digital one wasn't giving me good readings. There's a couple of reasons for that. Where I'm taking the measurement, it's directly after coming through the head. It's going to be fully turbulent. So I'm not going to get good readings based on that. I got to get the flow laminar, or basically straight line, right? Not all tumbling and twirling and all that. That way, in the 4-inch hole, it doesn't matter where I take a sample on there, right? It's all even. All the flow's even, all the pressures are even and everything. So that makes it a lot easier. So I've got to get to that point right there. The other thing is, if we look down here, I'm using my leaf blower, which has the mulching part of that, where it sucks in all the stuff and mulches it. So that is sucking in there, and every time a vane comes around, it's kind of like a piston firing. You get a pulse in there, a pressure pulse. So my digital device doesn't have any dampening on there, so it just reads like a peak and then a low and a peak and a low. So I can't see what's going on. Whereas this, the fluid in here dampens what's going on so that it's just stable in there, right? So that's a good direction, but what I really want to do, like I said, I want to get to where I have good straight line flow, so anywhere I check in that bore, wherever the sample tube is that I'm doing, it's all even flow in there, and it's good straight line flow, same pressure, same velocity. And then the other thing is I need to figure out a way to dampen out the pressure pulsations on there. So that's what I'm going to be working on. What I'll probably do is take this leaf blower and mount it so it's sucking in this way. So basically we'll come out of our deck 90, 180, try to do a flow tube somewhere in one or the other right there, because you want a good long enough run for it to get laminar. And then what you'll do after the bend, because before and after a bend, it's going to create some turbulence. But with my 3D printer, I can do some things you can't do with a tube, right? So we'll come in here, and then I'll probably put a little box in there where it has like an inlet down at the bottom, and then an outlet up here kind of at the top of it is what it would be. That way there's no direct line for the air to flow in. So it's also a volume, like a plenum volume. So every time there's a pulse, it has to move all that air, so it dampens it out, essentially. So that's the theory on there. I need to get to designing that and 3D printing it. I also need to make sure that I have all my hardware set up, figure out what I'm doing with this piece. That's probably the biggest thing right there. Let's take a closer look. So I didn't exactly know the height, and this is before I had a 3D printer. So I was guessing, so that's why I did the 2 pieces, and I made this right here adjustable. Now that I know that distance, I can set this up a little bit better and then try to get this to seal up, like redesign this. Because with my Mopar pattern right there, I need an adapter and everything to fits that, and it doesn't look real pretty underneath there. So I want to work on this portion right here first, the mounting, and get down to that hole right there and get this all cleaned up. So here's our tubes. One's facing up, so it's getting the total pressure in the system. So you have the static pressure and you have the velocity pressure. The other one's face down, so it's only getting the static pressure within the system right there, right? All right, coffee and Flowbenches, right? Doesn't get much better than that in the morning. So I have this apart to kind of see how I did the stud and a nut and a finish washer. Then I can adjust and level my plate on there. So pretty simple design there. And then if you missed the first part, I actually have the wood thread inserts that I put in here and then just threaded these rods down into it. So that's how I'm keeping that on there. So I'll need to clean all this up. You see our design here, our 2-piece design over on this side that is all jammed up. Anyways, the point that I want to get to with this setup is we need to have enough 4-inch bore adapter right here to mimic what the cylinder is doing. So I figure about a little over 4 inches, between 4 and 5 inches should be plenty. And where I'm going with that is whenever I connect over here to our actual bore down in here, since this is 4 inches, right, I can actually taper that down into there, and I don't have to worry about a connection here. I can just taper it down into there and have it stick out the bottom and just be attached to the top plate up here. So I think that's going to give me something a little better, and then I can neck it down to you know, come out and 90 that, and then neck it down to a motorcycle buzzing by. And he's so slow it takes forever for it to go by. I don't know if the new camera kind of noise canceled that or not, but it was very loud for me. So what we're going to do there is 90 out. So that gives me a good, if I come out from there, what is it, a good, to the edge of my table, 36 inches of straight run. And then I can reduce it down from there to, I think a 2.5 inch PVC pipe would be fine. Now, why 2.5 inch? PVC pipe is super smooth. That's why I want to try to use that, right? So I think I'll buy a stick of that and give that a whirl, do some tests on there, and then I can do the 3D print adapting down to it without doing a bunch of weird PVC pipe adapters. Once I get there, 90 come through, and well, we'll get to that. We just got to deal with the first part at a time, get all this cleaned up, figure out how I'm going to adapt it. And since this is the Mopar one, I got to figure out something, because that needs to be adapted and not get interrupted by the bore. And I'm going to need to do a forward plate at some point. So yeah, got to think on that one. Anyways, that's not for now. Now is coffee time. Okay, got that cleaned up. This is kind of the rough setup that we have for the Mopar head gasket. You see where bolt holes are, and I'm using 1/4-20s, and then I have like a little piece of rubber right there to go down in and help line that up. So one of the things is butyl tape. I'm getting it cleaned off, and the design that I had before, because I was guesstimating, because you know, the first round of it, we end up just, you know, sending the bolts through this flange and everything, and got the butyl tape all over the bolts and all that. So I'm going to clean all those bolts up, and this is going to be designed differently. One of the things I was waiting on, though, was the Ford gasket to come in. Now that I know what the Mopar layout is, I can do the Ford layout. And it's an important note that when you're looking at this, the intake's coming in this way. If that's how I'm going to set it up and flow it, make sure the head gasket's like that. Because if you do it like this, things don't line up right. So one of the little note things. So I'll just take my forward one and we're just going to line it up somewhere in here. Looks like, probably take it out of the package and look at it, but looks like that one almost lines up on that Mopar bolt right there. If I did that, the head would be crooked, but it's still centered. So I may be able to use these two Mopar bolts. I don't want to get it too far off because an overlap is going to cut our flow, right? But I also know the head gasket is bigger than the 4-inch bore. So I'll play around that and then mark it. You kind of see the idea I'm doing and put the appropriate holes in there. I may have to do something funny with it. It doesn't really matter as long as it goes on there and I can test it, right? And that's the point. And then it seals up and everything. So that's what I'm going to be tinkering with next and get this deck looking good. And I'm going to, once I get that down, I can redesign this so it can attach to the bottom of our plate, right? That side, and avoid any of our head bolt mounting holes in there. Don't have a clever way of putting that on there just yet. I don't really like the flat flange going in there method. You kind of see what I ran into right there, but that may be the best way to do it because I don't want anything to go up in here because that's already a 4-inch, right? I could overbore this and then make the inside of the tube 4 inches so it sticks up and I have a little lip in there, but it's still kind of sort of doing the same thing. So I got to think on what that design is going to be. I'll show you what it is and we'll get back to it here in a second. Alright, here's our little adapter here. It's centered up and you can see here's the Mopar holes covered up there. The Ford holes are there and then the little, you know, extra, I Sharpied that out where the new Ford hole will be right there. So, got a little bit more work to do. I probably could have made this a little thinner. Maybe do that next time, but this is our starting point here. And I think it'll behoove me to go ahead and print like a little sleeve to go down in there. That way I can get this centered in the same spot every time, right? Because right now I'm just kind of, you know, sort of getting it there. So we see I need to do a little bit of design here. I'm going to have to bring that out quite a bit and just have just a little lip in there on this edge, because by the time I do a nut and a washer right there, that's going to take up that room. These can actually be a little smaller. I plan on using something like that on there. That's what I was using before. And that would work, but I could make that just a little bit smaller in there so that we're not like that. So that's another reason why if I had a sleeve to go down in there when I'm putting this back, because this is going to go on that side, right? And I'm going to screw it in. So a sleeve I could drop down on there and get that aligned. So that's kind of the idea we're working with there. And I'll just have to mark this up however I think it should be and give this, I keep wanting to put it there. That's the other thing, is this kind of hangs over right there. So I need to trim that back just a little bit too. But this is an iterative process, and thankfully we're using 3D printers to do this because it's cheap and it's pretty easy to do, right? If I was fabricating that, well, I'd do cardboard. If I was going to do metal, I'd get a cardboard piece and hand cut everything out and get it the way I wanted it, and then I'd transfer that over to a piece of steel and then make it if I was going to actually be doing steel fabrication. But this is way easier than doing that. Okay, well, I'm going to go ahead and get all of that done, and then we'll see what it looks like then. Okay, redesign that just a little bit right there. Doing just a little slice. Let's see what we got going on over here while the printer's getting ready. Yeah, we're inside because it is obnoxiously hot. Anyways, so that's the markups. That's where we had this. I kind of marked up what I was doing there, and that's kind of how I come up with that. I also marked top on my plate because I don't want to get it flipped around because I'm going to forget by the time I get this project done. One other thing. So I picked up the street elbow because this side here is the 2-inch PVC pipe, right? ID, OD is the same, and then this is the mating side of that, so I can take my measurements and kind of make my own stuff. what I'm going to do is I'm going to take this 4-inch hole right here, and once I do the height that I want on there, I'll make the second piece look like that to slip up on it, but then I'm going to taper it down to this size right here. Then I can just do a 90, just buy the actual PVC pipe 90, a 10-foot stick, and then I can use a lot of that for all my pieces. I think the 2-inch is going to work perfectly fine. That can get in there and do what it needs to do, and it's readily available stuff. So it's kind of the thing of, I need to reduce it down a little bit so that this cross section I can get a good even, wherever it's at, it's even. If I get too big, then there's going to be a gradient between the outside wall and the inside, right? But I don't want it so small it's going to restrict it. But I should be able to get plenty of flow out of that. PVC is essentially perfectly smooth as far as your Reynolds number, the roughness calculation. It's got nice curves usually in there as well. Alright, just a little update on doing iterations right here. So we saw this one already, which is kind of the first general idea. Then from there, I developed this one right here, right? So I felt pretty confident with that fitment, so I went ahead and went with a full-on piece right there. No, it's not cracked. That's a Sharpie mark. I already lined it up there and kind of got an idea where it needs to go. Now, to get that centered up, what I did was I made a little ring that fits in the bottom and it sticks up above there, so I can get that centered up, right? Doing it one-handed, so it'll, well, I can't do that one-handed. Anyways, you get the picture there. It slides in there, sticks out, aligns it up. Alright, so the next part is actually taking our piece there and getting it down to our tubing size. So I pretty much got this one to fit pretty good right off the bat, right there, right? Because I already knew that it's PETG. I know the diameter of this that I made it to, and I know what to make that to. Make it the same, easy. This little ring, though, that is the exact same size as that fits in this other side, because essentially I'm making PVC. Trying to get that right was a little more difficult. So what we're going to do, we're going to make essentially a cone, right? That goes from there to there. So I've done my iterations on this. Took me about 4 tries to get it right. Again, whenever you 3D print, if I make this a 2-inch circle, it's not going to print a 2-inch circle. So what I kind of need to do is calibrate my filament so I know what that shrinkage offset's going to be, so I can just put that offset in to the printer and just draw it. Supposedly I can draw it 2-inch, put that modifier in, the printer settings, right, and it should be able to do that. That's kind of the next step. I've only had this for less than a year, so I'm still learning on some of this stuff, how to make things like this a little bit quicker, right? So that's where we're at. I'm marked where I needed to do all my modification and hole drilling. Then I can go ahead and get this assembled, and then I'll be ready to have my funnel on there, which I'll be able to do a 90-degree elbow on it. Once I get all that done, I'll show you what it looks like, and I think that'll top this one off for that video once we get all that done. Here it is. I've been playing with it, so I got a little gunky gunk on there, but that'll adapt down from our 4-inch, right? And then I'll be able to, not use a street elbow, do a 90. Then I can continue out with the 2-inch PVC pipe from there. So here's your upper deck plate, lower deck plate. It just fits down in that hole right there. Bolted to that, so we'll be setting like that right there. So that finishes that part of it. The fun part is going to be coming down here where I have the leaf blower, the suction part of the leaf blower for the mulcher attached directly on there. And that's what is causing a lot of my problems with getting good flow results, because it's so turbulent in there. So I'll have to clean all this out and take that out and readapt it and do my lines in there, but that will be another video. So I appreciate you hanging out with this and seeing how I did that right there. I'll see you next time on Broken Tool Garage.